Today our topic is defining sampling distribution of sample mean for normal oscillation when the variance is known and unknown. So today the topic is distribution of the sample mean for normal oscillation. So this is the title is a normal oscillation that it is only in the distributions. We need to find the formula and distribute. So here what two oscillation variance square root of 2 is known and oscillation variance square root of 2 is unknown. So that is two of sample. So first, the population has a mean and variance of 6 square root of 2. So this is the mean and variance of 6 square root of 2. So it's unknown square root of 6 square root of 2. Standard error 6 is equal to 6, so and it is another oscillation and oscillation of variance is equal to 2. In this distribution, this equals x minus mean over variance and variance of simple mean for normal oscillation. So that is the formula of distribution of C. And N of straight and greater than certain. So here the has a mean and variance, and we have a standard error and distribution and C, and N over 3 So next, population variance is unknown. We have a standard error and of S over N. But the same the population has a mean and variance of 6. What the current solution is here was unknown and known. So here what mean distribution E in equals x minus mean over S and over N. So it's all the mean distribution. That is the formula of distribution and the standard of error. 11 and 13. So, determine whether the following statements have a known or unknown population variance. Identify also the formula to be used to estimate the standard error of the mean. So this is the following statement have known or unknown population variance. Then we need to identify also the formula by using the estimate the standard error of the mean. So number 1, consider a population consisting of 1, 2, 3, 4, 5, 8, 9, and 11 samples of size 3 are drawn from this population. So we can see this number is a sample size of 3 are drawn from this population. So we need to consider to populate the consist is size. And from this population, yeah, we need an even. So this is an even. N is all 9 and N is all 3. In sampling distribution with the variance is known. Then we have the standard error formula. So this is the formula of standard error. So 6x equals 6 over n. So that is the standard error formula. And 2, given the population mean of log and sample standard deviation of 3, the sample size of 125. So this is the example of unknown. This is even, mean is all 12, and this is all 3, and n is all 1 and 5. So that is an example of unknown population variance. So we find a sample standard deviation of 3 in the sample size of 1 and 3 and 5. So 1 and 5. So this is the mean is also 3 and n is all 125. And the population variance is Retainer calculates finding the mean and variance of the sampling distribution of sample means. So this is the properties. So this our topic is the properties of the sampling distribution of sample means. So number 1, the mean of the population mean is also the mean of the sample mean and from the population, therefore mean x equals mean. So this is the formula of mean. And this is the properties and sample means. Sample means is given by a variance of the sampling distribution of sample means is given by 6 to x is equals mean probability represent x mean is square root of 2 or mean x is square root of 2 then probability x minus mean square root of 2 or 6 square root of 2x is equals 6 square root of 2 over n and times n relative n over n relative 1 for finite population without replacement n. And we have a 6 square root of 2x is equal to 6 square root of 2 over n for infinite population with replacement. So number 2, the standard deviation of the sampling distribution of the sample mean is given by 6 x is equal to 6 over 2 over n minus n over n minus 1 for finite population, where n minus n over n minus 1 is the finite population erection factor. So 6x minus 6 over n for infinite population. That's all properties of sampling distribution of sample means. So that is the example of sampling distribution of sample means. So we have steps in constructing the sampling distribution of the means. So number 1, compute the population mean. Number 2, compute the population variance. Number 3, determine the numbers of possible samples. Number 4, list all possible sample and their corresponding means. And 5, construct the sampling distribution of the sample means. And 6, compute the means of the sampling distribution of the sample means. 7, compute the variance of the sampling distribution of the sample means. Number 8, construct the histogram. So this is the 8 steps in constructing the sampling distribution of the mean. Example, a population consists of the number 2, 4, 9, 10, and 5. Let us list all possible sample sizes of 3 from this population and compute the mean and variance of the sampling distribution of the sample means. So a population consists of the number 2, 4, 9, 10, and 5. This is a possible sample size. Condition of the mean and variance of the sampling distribution of the sample means. So number 1, compute the population means. So that is the formula of the mean of x over n. Then 2, 4, 9 is actually so 2 plus 4 plus 9 plus 10 plus 5 over 5 is equal to 30 over 5. Over 6 divided by 30 over 5 is equal to 6. Then 2, compute the population variance. 6 square root of 2 x minus mean over square root of 2 over n. So 2 minus 6 square root of 2 plus 4 minus 6 square root of 2 plus 9 minus 6 square root of 2 plus 10 minus 12 square root of 2 and plus 5 minus 5 square root of 2 over 5. Square root of 2 is equal to 9.2. So that is the final answer if you compute the population variance. And 3, determine the number of population sample. So this is the formula of NC n is equal to n over n minus n
Peace.